Hi all, hope y'all had a really good winter break. We are going to review the first two sections of chapter 10 today. So we're going to review 10:1 and 10:2. Okay, so 10:1 was making predictions. Okay, and then what we learned in 10:2 was that in order to make predictions, you need to have a valid, unbiased sample. Okay, but we'll review the valid and unbiased in like 5 minutes. Okay, so to make predictions, we're going to use our knowledge of proportions and cross multiplying, and then we're going to remember or review that probability is the number of ways to get what you want over total number of possibilities. Okay? And so if it's asking for probability questions, that's what you want to do. You want to make sure you get your total, and then and you can just leave them as fractions if you want. The answers should come in fraction, decimal, and percent form, because you know how to do all of those in theory. All right. And then we can use that to predict by doing some cross multiplying to a bigger population. So let's just practice this a little bit. So we're going to have, there was a survey of middle school 7th graders, weird. Use the table to find the following probabilities and predictance stuff. So career field. So our little chart here has entertainment. And that's 17. And education. And that's 14. Medicine. And that's 11. And public service is 6. And sports is 2. Okay, so before we do anything else, remember, we're going to need our total. So we want to add all of this up. So 4 and 6 is 10. 7 and 1 is 8, plus 2 is another 10. So that's a 0, and then carry a 2. 2, 3, 4, 5. So they asked 50 students total. That's our total number. That's what's going to go in the bottom. Okay, so the first one says probability of choosing a career in public service. Okay, well, public service, that's a 6. 6 people wanted that out of 50. And then we reduce that. We can divide by 2, and we get 3 out of 25. Okay, next one. Probability of choosing a career in education. Education is 14. So that would be 14 out of 50. And again, those are divisible by 2. And we get 7/25. The probability of choosing a career in sports. Sports is 2 out of 50, which reduces down to 1/25. Predict how many students out of 400 will enter the education field. Okay, I'm going to move this one over because this is a predict. Out of 400, how many choose education? Okay, now we've got this here, and we've got the reduced fraction if we want it. We could use either one actually for calculating we just need one of those two fractions. So we can go ahead and use the reduced one. So we know education, it'll be 7 out of 25 people. And then we want to know how many out of 400 people. Okay? And so if we wanted to, we could be really quick about it. And how many 25s go into 400? And it turns out that's 16. And then you can multiply. So it should come out to 112. But if we do it the regular cross multiplying way, 7 times 400 is 2,800. And then we divide by 25. Can't wait to show, yep, 112. Can't wait to show you the algebra behind our cross multiplying. It's coming, it makes me excited. Okay, another one to practice that. Predicting again out of 500. How many will choose medical? Okay, so medical, we didn't do that one yet. So medicine is 11 out of 50. And then we set that equal to, we're trying to figure out of 500. And to get from here to here, we just multiply by 10. So multiply by 10. Okay, and so x should be 110. I will do the cross multiplying just to verify if it makes you feel good. 11 times 500 equals that number, and then we divide it by 50 and 110. There we go. Okay, and then the other way we can use to predict, this takes the most work, but remember we can also do from percents, right? And the percents are the easiest because you just literally take the percent of a number. Okay, so a problem that we can practice with that information. How are such big numbers? All right, so we have a pie chart, circle graph, whatever you want to call it. So we're going to look, our general population is 300,000. Okay, and it's 12 to 14-year-olds, but I don't think that we need to worry about that. That's extra information. And then it says, predict the number of teens in this age group who volunteer a few times per year. So if we look at this circle graph, we've got once a month, once a year, a few times a year, not at all, and once a week. So it was asking for a few times a year. Few times a year is 20%, which means we need 20% of 300. Okay, and if you remember with your percents, we change the percent to a decimal, 0.20, and we multiply it to our whole, 300,000 times 0.2, and that is 60,000 people. Whew. Those are big numbers. I don't know why they decided to make the numbers so big. Okay, so the first half of the worksheet is doing those things. A little bit on percent, like 3%, and then one set with the probability. No problem. Okay, then the other section, 10.2, was biased and unbiased. Now, do you remember which one we want? We want unbiased. So remember, we've got two different types of unbiased surveys. Flip to the chart just to make sure don't miss anything up. If you have your book with you, the chart's on page 802. Okay, so unbiased, which is good, smiley face, and it means our conclusions are valid. And we've got a simple random sample. The keyword for simple random sample is just, it will say random. That's the keyword for that one. Okay, systematic random sample. There's a pattern or system for choosing. So you're looking for like every 20th thing. Okay, so simple random sample, usually you'll just say random somewhere in the description. If it says every 20th person, every 100th cell phone, any of those things, that means it's a systematic random sample. And those are both unbiased, valid. These are the good ones. Yes, we can predict. So we can do all the stuff we did in section 1 if this is the type of samples we have. If we have biased, frowny face, those are invalid conclusions. And these two are convenience sample. Remember, that's just the easy people. And remember, biased and unbiased just means that people are either over or underrepresented. Your sample group does not match the population. Okay, so convenient sample is just asking the easy people. Voluntary response. This is asking people to participate. Okay, so those are the two kinds that are not so good that the book likes to talk about. And so we can just go over some practice scenarios. So this one says Zach is trying, I guess you could read along with me. These are just out of the book. Zach is trying to decide which of the 3 golf courses is the best. He randomly surveyed people at a sports store and recorded this. Is it valid? I think because they threw in that random, they were going for yes, it is valid. Next one, to find out how much money the average American spends to cool their home, 100 Alaskan families are surveyed at random. Ooh, they did throw the random in there, but is just asking Alaskan people going to be representative of all of the country? Do you think the temperatures in Alaska are going to be the same as the temperatures in like Texas? I don't think so. I mean, I say no. Just some more practice so that you can get a better sense. Let's see, this one says a magazine asks its readers to complete and return a questionnaire. Right there. Okay, a magazine asks its readers. This means it's voluntary response, which means it is biased, which means it is invalid. The student council advisor asked every 10th student, that's your cue right there. This is a systematic random sample. Therefore, the conclusions are unbiased and valid. So then it says the results are shown in the table. Is it a random sample? Yes. Suppose there are 800 students, and then you could use the information to predict. Okay, so you'd want to add all of this up. And let's see, and it's asking for email. So you add it all up, and then you put 16 over the total, and then you set that equal to this, to x over this number, and you cross multiply. And that's your good practicing on that. Bye.